Okay, so day 3, radicals. So we have the nth root of AB, which could be separated to the nth root of A times the nth root of B. Sometimes it's helpful to have it separated to break down. Other times you want to combine it together to go back here. It just depends on the problem, what you're trying to do. The nth root of A over B, it's going to be the nth root of A over the nth root of B. The mnth root of A, the mth root of the nth root of A is the mnth root of A. You multiply the two indexes. The nth root of A to the nth, now normally we kind of just say those cancel out, but what you really need to know is it's just the absolute value of A. So basically, A without a sign on it, just positive. Absolute value of A if n is even. And is even. And it's A if n, oops, oh, jeez. And it's A if n is odd. Okay. The nth root of A to the nth power. Another way that you could write that is it's the same as the nth root of A and then all raised to the m. This is a very helpful property because a lot of times, like if you had to do A to the nth and then take the nth root, you'd be taking the nth root of a very large number. If you take the nth root of A first, it'll be a smaller number, and then you can raise that to the nth power. So that's a useful one. And we're going to see all of these properties then used in some examples. A to the 1 over n is the nth root of A. So the top number is the exponent, the bottom, the denominator is the index. So that's why when you come over to this one, this means the nth root of A, and again, raised to the mth power. So the bottom is the index, the top is the exponent. Okay, so for this next one, so this is going to be a little review of exponents, but then there's also going to be some radicals in here. So if you look at negative 1/8 to the negative 1/3 power, remember we said with negative exponents, you flip the base. So negative 1/8 goes to negative 8. And when you flip the base, the exponent becomes positive. So sometimes people, think that they have to change the sign on the base. Negative 1/8 still stays negative. It's just 8. Then the exponent is positive. So then this means the cubic root of negative 8, and the cubic root of 8 is negative 2. So sometimes here people will say to me, well, I thought you can't have a negative under the radical. You can, you just can't under square roots, right? So you can under a cubic root. Okay, and then the next one, this would be the cubic root of negative 1,000, which would be a negative 10, right? So when you're doing a cubic root, you want to think of what thing that you multiply 3 times would give you what you're taking the cubic root of. So if you think about it, negative 10 times negative 10 times negative 10. So now when you do this, you're going to subtract 10 times 10 times 10 is 1,000. Negative times negative times negative is how you get the negative, right? You've got to get this thing back again. That's the same thing over here. Negative 2 times negative 2 times negative 2 is a negative 8. So that's why you need that negative. Okay, so we looked the other day at power exponents. When we're raising a power to a power, we multiply. So 2 times a third is 2/3. Y to the 1/3. Then this is x to the 2/3. Y to the 2 times 2/3 is 4/3. Right, so you just take 2 over 1 times 2 over 3. Fractions you multiply straight across. And then this is x to the 2/3, y to the 2/3. Okay, I'm going to clean up the numerator. So x to the 2/3 times x to the 2/3. So remember, when we're multiplying with the same base, we add the exponents. So this would be, actually, you know what I might do here, because this will be a little bit easier. Since these are the same, x to the 2/3 and x to the 2/3, I might just reduce those. We can do that because it's factors. If there were a plus or minus sign in here, we would not be able to cancel those. But because it's all multiplication, we can cancel those. So now on the top, I just have x to the 2/3. Y to the, so now this is where I'm going to add, this is y to the 5/3 over y to the 2/3. So now what we have to remember with division is you subtract the exponents. So this would be x to the 2/3, y to the, okay, 5/3 minus 2/3 is 3/3, which is 1. So this is my answer. Now it all depends. Okay, this said give your answer in simplest radical form. So if we want to give this in radical form, the y is going to stay out in front. This is going to be the cubic root of x squared. So sometimes it might say leave it in exponential form. This would be exponential. This is the one I have circled is your radical form. Okay, multiplying radicals. When you multiply radicals, you multiply the whole numbers or integers, whatever they might be, and then you multiply the radicals. So you have to multiply a radical with a radical and a, integer with an integer. So 3 times 2, I would say 6, and then radical 12. And then this is where you know from previous years that you can break down the radical 12. Radical 4, radical 3. So remember, when you're dealing with breaking down radicals, square roots, if they're square roots, you're thinking of perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, right? So on. You've got to think of your perfect squares. So that's how I knew 4 went in. This is then 6 times 2 radical 3, because the square root of 4 is 2, and then giving you an answer of 12 radical 3. So that would be the answer, simplest radical form. Here we have 2 integers and then just a radical by itself. So we multiply the integers, 10 radical 3. That's my answer. Here we've got an integer and then we got 2 radicals. So the integer is going to stay, the radicals we're going to multiply. We want to recognize that radical 36, square root of 36, that's a perfect square, which is 6. So my answer is 30. Okay, adding, subtracting radicals. You need like radicals to be able to combine. So we have to see when we break it down, we'll see if we have like radicals. So again, we're thinking of our perfect squares from up above, right? We got to think of these when we come down here. 18, we'd break to square root of 9, square root of 2. 8, we'd break to square root of 4, square root of 2. I usually always put the perfect square first because then that's the one we're going to take the square root of. Square root of 9 is 3. Can't take the square root of 2, right? That's not a perfect square. Square root of 4 is 2. So we've got a negative 3 radical 2 plus a 4 radical 2. So I'm going to combine my integers because I have like radicals. I have a radical 2 and a radical 2. So I get a 1 radical 2, which we just write radical 2, right? You don't write 1 radical 2 just like you don't write a 1x. 1 times anything is that thing. Next, I'm going to a cubic root. So now if I get a cubic root, I've got to think of cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed 125, 6 cubed 216. Those are helpful ones to just kind of know. Those are cubes. Okay, so the first one, I can't break down the cubic root of 2, right? There's none of these numbers aside of 1, which 1 doesn't help you break down anything, but none of these go into 2. 2 might go into them, but they don't go into 2. Now, 54, I'm going to break that into 2 cubic roots. Be careful. Sometimes people, when they're doing these, they get a little kind of sloppy and they forget their cubic root. So just be careful of that. So now I would have to, either take your calculator or just kind of think about it. What's the biggest of these cubes that goes into 54? That would be 27. 27 times 2 is 54. So that's what I'm going to break that to. So this says 5 cubic root of 2 minus 2. Now, cubic root of 27 is 3, because 3 times 3 times 3 gives you 27. And then, okay, so then we have a negative 1 cubic root of 2. Again, I don't need to write, and I shouldn't write the negative 1. It's most simplified like that. If you want to write it first and then rewrite it without, that's fine. Okay, so for next one, same thing, cubic root. So I want to think 1, 8, 27, 64, right, so on. So when I'm breaking this up, now we've got some variables in there. So cubic root and cubic root. So I'm breaking up the first one. I still have minus cubic root of 2x, which I can't take the cubic root of 2, and I can't take the cubic root of x. So here, okay, so 8. I have to look for which one of these cubes, or I'm sorry, I said it. 16, which one of these cubes go into 16? 8, right? So then it'd be 8 times 2. That gives me 16. Now, the x to the 4th, I have to look. So as far as exponents go, I have to look for what's the closest number to 4 that will be divisible by 3 without going over. So that would be an x to the 3rd, right? Divisible by 3 would be 3, 6. As soon as I go to 6, I'm over 4. So now here's what you want to check. X to the 3rd times an x gives you an x to the 4th. So we're on the right track here. So the cubic root of 8 is 2. The cubic root of x cubed, remember you divide those. So 3 divided by 3 is 1. So it's an x to the 1st. And then you got cubic root of 2x minus, this is a 1 cubic root of 2x. So if you need to write that in there to kind of help you as you're doing your work, we have these are in common, so I can subtract, and I can't combine those, right? They're not like terms, but I just have to say 2x minus 1 in parentheses, cubic root of 2x. If you don't put it in parentheses, it'll look like the cubic root of 2x is just with the 1 and not with the 2x, right? It has to distribute to both. So you do need that in parentheses. All right, next one. Okay, we're going to break this again. Cubic root minus, all right, this next one looks like it's not going to break down, so we can just leave that cubic root of 2xy. You can't take the cubic root of 2 or the x or the y. And then for the last one, plus 5, and then yes, we will need to break this into cubic roots. Okay, so again, this is 8x cubed, which means we still need a 2, right? 8 times 2 is 16. X to the third times x is what gives you x to the fourth. And the y would go over here because we can't take the cubic root of y. So this is a 2x cubic root of 2xy minus 3x cubic root of 2xy plus 5. Okay, so let's see. In this last one, when I'm looking here, the only thing, can't take the cubic root of a negative 2. Well, take the cubic root of a negative. You can't take the cubic root of 2. So I'm going to put the negative here. I'm going to put the 2 over here. Can't take the cubic root of x, so that's going to go here. Cubic root of y to the fourth, this could be y cubed, and this is y. So remember with the exponents, you want something, if you're doing cubic root, you want something divisible by 3. If you're doing a fourth root, you want something divisible by 4. Okay, so the cubic root of a negative y cubed. So remember, you can take the cubic root of a negative. Cubic root of a negative will be a negative. And then y, cubic root of y to the third is y. And then here you have left cubic root of 2xy. This is perfect because I've got all these like radicals. So that means I can subtract the coefficients, 2x minus 3x. Well, that's a negative x. And then minus 5y. And then cubic root of 2xy. Again, that does need to be in parentheses. All right, if we're breaking down some divisions here, or in this next one, now here it's separated. Sometimes it's helpful to separate it. Like if I could take the square root of 500, then I would just, kind of leave it separated. But I can't take the square root of 500. Now what I have to think is, what's 500 divided by 20? That is going to work out nicely. So I'm going to put it all under one square root. So 50 over 2 is 25. So this becomes square root of 25, x cubed divided by x is x squared. That's nice because that's a perfect square. Square root of 25 is 5. Square root of an x squared is an x. So sometimes you have to scan the problem to see, like, should I leave it separate, or is it something that's going to divide nicely that I could put under one radical and take the square root of? Okay, for this next one, we have x to the fourth y cubed to the 35 divided by 7, right? It goes, the exponent is the numerator, the index is the denominator. So this is actually x to the fourth y cubed to the fifth power. And then we know power to a power, we multiply x to the 20, y to the 15th. So as I said, this will also practice exponents. Okay. All right, so for the fourth root, so fourth root of 81 is 3. That's because 3 times 3 times 3 times 3, 4 times, is 81. And then it's x to the 8 fourths, y to the 4 fourths. Since those are both divisible by 4, this is really just x squared y. So those have to be, if the exponents are divisible by 4, you can just, take that fourth root of it, divide it by 4, the exponent. If it's not, that's where you have to break it down like we were doing above, which I think we'll see in the next one. So breaking these down individually, not probably so nice. So I'm going to multiply them first. I noticed that 2 times 18 is 36. 36 is a perfect square. So since I'm doing square root, I want to multiply those. 36 x squared times x cubed is x to the 5th. Y to the 5th times y squared is y to the 7th. Okay. When I'm breaking those down, square root of 36 is 6. Now, when I want to break down, the x to the 5th, y to the 2nd, I want to think of what the perfect squares are. So I have to have the largest number closest to 5 that is divisible by 2, right? Square root, they don't write the index, but it's understood that there's a 2, right? So this would be x to the 4th, which leaves an x over here because we got to have x to the 5th when we multiply. Y to the 7th, closest number divisible by 2 to 7 without going over is 6. So this is y to the 6th, and then this is a y. So this is 6. This will be x squared y cubed, right? 4 divided by 2 is 2. 6 divided by 2 is 3. And then those are non-perfect squares under the radical. Okay, so the next one is all under 1 cubic root. So you have to ask yourself, is it going to be something like, what is 54 over 2? 27. So yes, I want to leave it like that. If it wasn't, then I might want to separate it to a cubic root on the top and a cubic root on the bottom. But this one, cubic root 54 divided by 2 is 27. If I reduce here, I get an x to the 3rd on the bottom, and I get a y squared on the top. Or I'm sorry, I get a y on the top because I have y squared over y. So I have a y on the top and an x cubed on the bottom. So I'm doing the cubic root of all of that. Okay, cubic root of 27 is 3. Cubic root of y is just the cubic root of y. Cubic root of x cubed is x. Okay, so square root of 3, no, we can't do it. Square root of x, no. I don't even want to write it into one radical because I can't. 3 divided by 8, that's not going to be something I could take the square root of. So I'm going to leave it. I'm going to break down radical 8, which is 2 radical 2. And then this is where, in previous years, you can't leave a radical in the denominator, so you rationalize the denominator. And I only have to do that with the radical 2 because that's the one that's giving me the problem. That's the one that, is a radical. So this is radical 6x over 2 times radical 2 times radical 2 is 2. So this is radical 6x over 4. Okay, I think we're just going to look at these last two here. Okay, so this is rationalizing, but we have a binomial in the denominator. So radical 2 minus 1, radical 2 minus 1. Okay, so this times this, radical 6 minus this times this is a radical 3. Down here, we're going to have to FOIL. Radical 2 times radical 2 is 2. Outers minus radical 2. Inners plus radical 2. And last is minus 1. So notice the reason we multiplied by what's called the conjugate, the opposite sign in the middle, is we want, that negative radical 2 and the positive radical 2 to cancel each other out. We don't want to have a radical on the bottom anymore. That's the whole point of us doing this. 2 minus 1 is 1. We don't write over 1 because divided by 1 really just gives us same thing, the numerator. So we have radical 6 over radical 3. Last one, we are going to multiply by the conjugate again. So this would be radical 5 plus 2, radical 5 plus 2. And so first, radical 35. Outers plus 2 radical 7, right? Because you can't multiply a whole number by a radical other than just leaving the whole number out in front. Here we're going to FOIL. That's 5. Outers, 2 radical 5. Inners, minus 2 radical 5. And lasts, minus 4. So again, notice the whole point of doing that is in the denominator to get rid of the radicals. So on the top, we've got a radical 35 plus 2 radical 7. Over on the bottom, again, we get 1. You will not always get 1, but, and so then that would just be this. Okay, that's it for radicals. You have your day 3 homework. I expect that there will be a lot of questions on radicals tomorrow, so which will be fine because we have no new notes tomorrow. So you can use your time on Zoom to ask questions. All right, hope you're all well.